Kubernetes itself.
Yes, thank you for the introduction. Thank you for the warm welcome and the great pizza. It was really delicious, I must say. Yeah, I think nobody knows me, and because of that, I will tell something about me and Loodse. What's our plan to tell you today? First, I want to show you the basic setup, how Kubernetes clusters will be built up if you build it by your own or you run it in the cloud, like AKS or something like that. Then, what's the new idea? What's Kubernetes? So what we are doing there, and why we think a ClusterAPI is a better approach to deploy nodes than the old way to deploying nodes. And there I bring some example how easy it is to integrate a new cloud provider to our stack. So we integrated Hetzner. Hetzner is pretty good internet provider for fast VMs, and unfortunately they currently have no storage, no load balancer as a service, but they're working on that. We are in touch with them, and they say they will bring up storage as a service this year maybe. And the plan for next year will be also that they can offer like load balancing and all stuff that you need like for real production ready Kubernetes infrastructure on a cloud provider. Yeah, and then I will show you how we can use ClusterAPI to create nodes just by definition. And yeah, what's the state, what's the pros and cons, and where is it going? Good. Then first of all, to me, I'm not an ops guy, so I came from the Java development, and there I got to setting up test infrastructure for test automation. Basically we did like containerized UI testing. So we did like running kind of Selenium tests inside of Docker containers and do it like in a real UI, not just a headless browser. And thereover I came to Loodse because I was contacted by them, and now because of this experience to have like a Kubernetes and containers for test environment set up was so helpful. Now I came to this point and try to also involve to setting up Kubernetes cluster and to get deeper into topic. So a few words about Loodse. Who of you know Loodse already? Oh, cool. So pretty few people. So we are founded in 2016. The headquarters is in Hamburg. We are currently 25 employees plus worldwide. So we are growing currently quite hard. And the basic idea of our company, we want to hire people who are deep in the topic and not where are they located. So I'm located in Munich, and the headquarters is in Hamburg. So we basically don't care. All the setup is mostly remote, and yeah, but we still meet up like one time in the month or 2 times in a quarter to do some hackathons and so on. So, and our mission is to work on cloud native technology made mostly on Kubernetes, but we also support like cloud, basic cloud consulting, something like for the GCP cloud, because we are also Google Cloud partner and we do some trainings there. And also we are a member of the Cloud Native Foundation. It was pretty cool because there are not so much members in Germany. I think it was 2 or 3. And for us, it's a good way to get the first inside information directly from them and also be in the decisions, what be the roadmap, and get this information like in the first level. Yeah, and we built up Kubernetes. Kubernetes, in a sentence, is like a multi-hybrid cloud container engine which tries to deploy multiple clusters in different cloud providers. So you can deploy it on premise and you can deploy it on public cloud, and every time over the same way. And the thing is that we can operate it from one single instance. So we can run operation task for 1,000 clusters on one meta cluster. And there we can control all the stuff, like with Kubernetes base metal, we can control Kubernetes installations. So this makes it pretty easy for us for like operating stuff, because if a cluster have a problem, I just use kube control and look into the objects, what's the problem? And that's the basic idea also for ClusterAPI. So that's the reason why I'm here today. So, but to start, Kubernetes, what's the basic Kubernetes deployment? So mostly the basic Kubernetes deployment has a master. That's the first you have to start. So you have to build up an API server and a controller manager and a scheduler, and for your data storage, etcd. So that's mostly the components you have to build up. There are a good installer for that, like kubeadm or like Docker Machine for local stuff or something. There's basically the problem is solved. But if you think around, if you have to build this like for 100 clusters, you will come to a point of automation. And there you have to maintain all the stuff and have to ensure that you have backups, that you have the etcd running in like in a HA setup. And there you have like operation for your Kubernetes cluster. Kubernetes clusters were, and this should also solve your operation of the Kubernetes cluster. So that's the basic idea behind it. Because then if you have the master cluster, you have to add nodes, and then nodes have to also be installed like kubelet, cAdvisor, kubeproxy, and maybe some network plugin or storage plugin we already heard. So you have to do a lot of configuration there to bring up new nodes. And if you are thinking of bigger environments, you cannot maintain 1,000 nodes by your hand. So you have to automate it. And therefore, you can start again writing scripts. And what's the pain about scripts? They have no state. So scripts just executed on one time, and they don't have like, they don't care about what's the current state. So this is kind of, engineering process. Then you can write smart scripts, but there are still scripts. So that's mostly a problem. Also, if you use Terraform, I think you will come to a point where you have like parameters, and then you try again to do a lot of stuff. And we try to simplify that, and not we only, so also the community. And that's what's about the ClusterAPI. And ClusterAPI is an official Kubernetes SIG project. So it's a sub-project of SIG cluster lifecycle. And there are projects underneath like COPS, kubeadm, Minikube, you already know, I think. So there are some repos. You can take a look at that. The old one is Kubernetes kubeproxy here. The new one is Kubernetes SIG ClusterAPI. So if you want to see what there is going, you can get in touch with them. They have a Slack channel. They have, I think, weekly or bi-weekly meetings where you can discuss with them. They're pretty open to it. And you get like first sight information about that. And there are main participants like Google, Red Hat, Heptio, VMware, and me. And these are like our part is to like we implemented already in a similar way. We have now migrated to ClusterAPI because the concept is the same. It's just like naming fields differently. But this is not getting standard. Why we want to have this as a standard is that you can build tooling around it. Because if you have like cluster object, the same way you have like a pod object, you can do more things about it. You can maintain your clusters over API. You can say, okay, cluster, please upgrade. So, and then you have a mechanism or a controller who controls the upgrade process. And so this basic idea that you get more features around this basic cluster API, which all people speak. I think the same like storage. Provider will provide how you can create by them machines. And then the tooling around that can then work with them. And you can monitor, you get like in future plans, you should get billing information. So then you can like compare what's the cost of different machine provider and then choose what you want. So that's like plans. Okay, so a few words to Kubernetes. Kubernetes is like, I think the first production launch was a year ago. Now we have implemented current cloud providers on public cloud side is Hetzner, DigitalOcean, Amazon Web Services, Microsoft Azure, and Telecom Cloud. But I heard the Telecom Cloud is like kind of cancelled. Yeah, but we can if you want. Also, like on-premise, it's mostly OpenStack and VMware, and there is also like fork of OpenStack for URI. You also can speak with them, and also bare metal. So there is the use case that you like if you have a big data center, or that you get away from the virtualization layer and use a bare metal system. And there is the idea behind that you provisionize like over Pixie Boot the new nodes and say, okay, Pixie Boot, please install Kubelet, please install that and that, and join the cluster. There you have like to pre-configure some machines because you cannot like find out what is reachable per Pixie Boot. So you have like a database or some kind of source for your to know. All other stuff is like provisionize the cluster ad hoc, so we don't hold some resources, so we just create it when we need it for a new cluster or if you want to scale the cluster. Good, but going back to the node deployment, so that's the basic idea of ClusterAPI to improve that. So like I already said, there are much tools out there how you can create your clusters. You can create it over the public clouds. So that each cloud has its own specific way of doing that. And more or less, then you are more or less stick on them, not only on machines, you will stick on them with their solutions. So like accounting, like how say cleanup builds, how the monitoring and also like backupping mechanism work there. And that's like, yeah, you get more dependent on the cloud. And there are some other way to provisionize like Ansible or Terraform. They work mostly well if you look in small, or we say you want to manage 3 to 4 clusters. But if you want to manage 100 clusters, there will be get a problem then. That's the use case. What we want to solve with ClusterAPI is not to automate one single Kubernetes installation. It's already solved. So it's more like operating multiple clusters. That's the target, or over multiple clouds, over one interface. And okay, I already told it. The current approach is you need ops guys to scale the cluster. So mostly if you have clusters and see, okay, the cluster is full, you would add nodes. Because this is like a task you have to give an ops guy or to an organization to give someone a new work. Mostly the companies go this way that the clusters get the size too big. Like in OpenShift, you mostly have like one cluster for the whole company, and they have just different namespaces. And if you build this up, say build up mostly like this space. But this space you have to pay. You have to pay with machines on private cloud as well as on public cloud. So, but you may use it in a year or something, and because of that, you don't want to. You cannot do it like on click, and that's not the approach you want to be to save costs. So, in the next step of ClusterAPI would be that you implement like a horizontal node autoscaling. Google already have it for Google Container Engine. So there, say, like find out what capacity the cluster needs and then scale the cluster up and down. Upscaling is not a problem because upscaling is easy. You can just add something. The problem is more downscaling, because downscaling is the harder use case. You have to decide which node is the cheapest node to destroy. Because if you like have stateful sets or something, it could be a problem. So you have to choose smart, and also may your architecture have to know about that the nodes will gone. But you have a good cost. You can save costs there. Like we already use for our master cluster. Sometimes we use KKE as basic cluster, because there you can use infernal machines. Some node machines will just live for one day and then say kill it and reschedule it. And these machines are like, I think one of a third cheaper than the normal machines. Why Google do this? They want to fill out the gaps. They want to be able to reschedule the machine where gaps are in their big data center. And I think in a small way, you can also do it in the data center. Or if you have like a data center with a limited capacity, you can add nodes maybe from the cloud. and or shift clusters to the cloud, and then that you can manage multiple environments. And think about like comparing two different cloud providers. If this is extremely hard that you migrate from one cloud to another cloud, there will still some project costs, and then you cannot like compare it vice versa. And that's the problem we see with the current way of static deployments and scripting. So, so how ClusterAPI works in technical reasons. So you have like an infrastructure provider, and this could be like AWS, Azure, or on-premise, whatever. And that's my providers. And the providers has provider-specific configuration. So like machine type. This is some called different in AWS than in VMware. I don't have the machine type. I can specify CPU and RAM. So, but they all have like common things around. So I want to install the basic operating system. I want to install kubelet. I want to install Docker engine, and those are the same informations. And that's the idea is here to use it. But first, that you can install a ClusterAPI, because ClusterAPI is a custom resource definition, you need a bootstrapping cluster. So you strap up with existing tools, bootstrap a machine cluster, and there you have like your normal Kubernetes setup with etcd, and there you have a ClusterAPI server or just have installed the custom resource definition. Then what bring the custom resource definition into the cluster? It's a controller manager, like a custom controller, which can control machines. And the machines have like the object then machine and MachineSet and clusters. So you have like get clusters, you can get a list of clusters you created over there. And in the user cluster, we see it later, then you can kube control, get machine, you can see what machines you have. Then inside of the machine controller, you need this provider-specific part. But if you want to have like 5 VMs or 5 machines of Azure or VMware, should be from perspective, from specification, should be the same. So there we place in like our Kubernetes machine controller. This is like our implementation, how we use it, and how we provision AWS, Azure, and VMware. So currently the provider are not really ready with their implementation of ClusterAPI. It's like rely on the ClusterAPI because ClusterAPI is in alpha state. So what we do, we just make fork, froze it, and bring it production ready. And then after we see it, there are some new features, we make the thing again. And this works very good. The good thing, if the ClusterAPI will be released with some stable API, we will be mostly the first who can use it and are like speaking ClusterAPI in an official way. So what then is happening? So the controller takes care. I say, okay, I want to cluster a new cluster. I want to have master components, and then want to have node components, and then define it in a YAML. And then the controller takes care to create it. Like you said, Kubernetes itself is like, you define a state, and Kubernetes should be able to create the state. And that's here the same. You define the state of the cluster, and the controller will take care about that the cluster get created in this kind of state. And if you change something, the controller gets a notification and can also like delete machines or something like that and reconfigure it. And that's you have to think about you maintain your clusters like you maintain your pods and pod sets or replica sets and all the stuff. And yeah, then you can bootstrap the clusters, and so therefore first the API server and the control components will be installed. So you have like then the user cluster API server, and with also an etcd running, and this is like installed by QADM in technical detail. And then they will connect it to the master server. So get the controller get the information. Okay, how can I create new machines or something like that? Then he see, okay, I specified there like 5 node machines. Oh, there's nothing. So this controller gets started and triggered their machine controller, and then new node machines will be added. And the same way you can do is with cluster upgrades. So you can like define, make not a live update. So you just add new nodes. So not maintain the nodes. More nodes like kettles. You handle nodes and machines like kettles, and that's the new way you want to maintain it. Because I see it in the past. I did some OpenShift consulting, and there was like, oh, the node running full. I do SSH there and clean up the Docker cache, and oh, maybe we should write a job for that. And then you're building up your own maintenance cycle, and okay, it works for that version. Then you have a new upgrade. Then all things is changed. You do it again and again and again. But why say maintain the nodes? Because it was too hard to create it, and that was the reason. If you have can do it like Google on Google Cloud Platform, click add new node, and it's there. You have no reason to maintain it or just add a new node if there are some problem. And if like the node is not ready, the controller will recognize it. They have like a timeout of, I think 15 minutes is the default. Then if the node is dead, say delete the node, spin up a new machine. Okay, then if you can create one cluster this way, you can create multiple clusters.
I have a question with the SIG on the master machines. So if you create a highly available master system, is the SIG governed or managed by the Kubernetes cluster itself, or is it externalized? Because then you cannot throw it away so easily.
Yeah, this picture is for the ClusterAPI. Say don't specify it. In our Kubernetes installation, the etcd here and the API server run inside of that cluster. So we manage this cluster, and we have a containerized API server controller manager in etcd, and we manage that things in the master cluster, and you can have multiple clusters. So you can have master cluster, C cluster, and then customer cluster to bring master components near to the data center. And the nodes are outside of the control. So yeah.
So the API, again, the API server is currently not running in the cluster A essentially, but it's running in the
on the Kubernetes. Yes.
So
I can maybe just open my slide. So that's like the standard which are maintained by the how I get the right presentation, but it should work. So Kubernetes, we do it like we have the master cluster already set up. Can skip that. So, and there are master components, and we have some workers for the master cluster. Traditional Kubernetes cluster. Then you install Kubernetes. It's just a hand deployment at least. So there will be included our cluster resources and the old stuff and the controller. And that's like our API controller and our machine controller and the UI to create a cluster. What you then make, you make the new user namespace with Kubernetes master components, and there with like the user cluster, API server controller, scheduler, and etcd. So in the next step, get joined. And so you do it for one cluster, you can do it for more cluster. And if you have like a distributed data center, you not want to have like the master components in Germany and the workers in China. So you want to bring the master components also to China, but also want to maintain it, not in traditional VMs like Ranger did it, deploy VMs for the master components. So in this way, we have like C clusters, and that's are also like Kubernetes known cluster. And we go over the C cluster, deploy there the master components, and from that C cluster, the worker nodes get deployed. Yeah. So what the good thing is, you can run for all side of this. You can run like our backup jobs. You can then monitor it all of different cluster sizes overall. And if this cluster have problem with the master components, it don't affect others. It's also like if you get bigger and bigger. So you have like a scalable way. Yeah. And so this could be like a setup could be that you run like master components in VMware and you have this user manage your own internal VM clusters, and there you have like Azure just running over SIG components.
I already have 3 more questions, but please continue with your previous presentation.
Yeah, we can do it later on in detail. So, yeah. So, yeah, I searched a picture. All right. So, was there. So, in the next step, you have like outside events, and you have like upgrade triggers or later on maybe auto scaling events. You already can speak with the API, so you can like create scaling in kind of cron jobs or in kind of a Prometheus matrix. Then you trigger the API to scale down, scale up, but it's not like an auto scaling. It's like more diagnostic scaling you can already implement. And then, but the same, what changes is the cluster YAML and the machines YAML, where you have the Kubernetes configuration, how a cluster looks like, will be changed, and you apply it more or less to the cluster, and the controller will take care that the cluster get to this state. And if you delete it, then the cluster will take care to delete all the resources. And so that's the cool thing, that you just can say like an upgrade, I changed the version of Kubernetes, and the controller knows how to upgrade the cluster, and it's different. So you don't run the script again, so just define another state. All right, so how this integration looks like more in detail, I think we already have talked a lot about it. You make like you can do like kube control create machines by your own, or do it over the Cluster API server who manage that. But you can then have like machine objects. You can handle that, you can maintain that, you can look into that like normal pod and deployments. Okay, what's a machine? Machine is a declarative spec for nodes, but it's not the node itself. So it specifies like the virtual machine where the node is running, and inside of this machine there is like a property like the kubelet version, which is the node. And then if the VM starts and install Docker, install kubelet, joins the cluster. And yeah, so how the code look like? So this is like a spec how you can create a node on Hetzner. That's all. That's like you define a type, it's machine, you can already read it. Then you have like SSH key, which we added automatically if you really want to look at the node. I really didn't do it quite a while, but you can. And then you specify like a cloud provider. And this part here, oh, damn, where's the pointer? This part here is the cloud relevant difference. So only you specify what's the server type, like your token, and that's really cool on Hetzner. The API is really small, so it's really readable. And then you have operating system. That's not the cloud provider spec, so it's just a general specification what you want to run there. And so you see, it's like learning a new Kubernetes object or operator object. It's like the same you specify maybe your Postgres SQL database. All right, and you see the namespace is still alpha. We already don't know when they will get better, but okay. And the machine controller then uses provide specific information and know like thinking like a driver, and uses like implementation and knows, oh, okay, I'm now on Hetzner. I have to call this API to create a machine with this sizes. I have to create a network there. I have to create maybe some security crews for virtual networking, and something like that. So that's then specified there, how you can add then your machines to your cluster. And like the algorithm is like you watch for a machine or a node change. So you take a look if the machine the specification has changed or just created, and then or the node is not healthy. Then you say, okay, execute the machine, and then check, okay, have a deletion timestamp. Why you think if I delete the object is gone? In this case, you cannot, because if you delete the object, no controller can know what to delete. So if you delete the object, this is let the controller keep it and start the deletion process. And after the deletion process is gone, you delete at least the object. So you have like a delete timestamp. So as long as you have like a state deleting, if you take a look, then you see deleting. It's sometimes you block it. For example, if you have like created a service with type load balancer and it's bound to a load balancer, we won't delete the cluster. So we stop the deletion because you have to. You cannot delete the load balancer instance. So you have to delete this first or be independent of the cluster. Yeah. So if then or if you're not in the delete use case, you say, okay, if I have the specification don't fit to an instance, or if I identify not the right instance, I want to create one. And after I create one, I wait how the time. First of all, I get information from the cloud provider. Okay, the VM is started. After this, I wait until the kubelet connect to my cluster, and then I say, okay, the machine is ready and the node is ready, and I can get some working load on that. All right. Yeah, and in this great example, you have like the render the user data like CoreOS, Ubuntu, CentOS. There are each cloud provider, you may have a different way how you can achieve to deploy an Ubuntu or an CoreOS. So like in VMware, you have different templates you specify in the installation and say, okay, if I use like CoreOS, I use that one. And you can even specify more if you want, but that's like standard. And in AWS, you use like a cloud image, and then we use mostly cloud, what's the name, cloud init, to then provisionize the machines. Okay, good. Then that's the provider interface. If you go to the Kubernetes ClusterAPI repository, there's the provider interface. Each provider has to specify. So if you want to bring your own, like for maybe ARM devices or something like that, you can just have to implement these methods like first validate to check what's the state of a machine. Then you have to get, so how can I identify a machine again? That then also like a get cloud config, so that's like transfer between the spec to the specific cloud provider config. Yep.
Do you implement the provider yourself, or
huh?
Do you implement the provider yourself?
Me, no.
Yep.
Yeah. You already
write all the, for instance, for all these famous providers, you write the investment.
Yeah. So we speak with them the API. You can take a look at that. It's open source. Or you can add your own if you want. Yeah.
Like
if you
paranoia.
Yeah, you can. So the whole Kubernetes setup is not open source, but the machine controller is so. But you can install the machine controller to your cluster and then build your own UI if you want. Yeah, and then you have to specify to create how to create a machine and to delete machine. So, and for Hetzner, it was pretty easy. It's like a 300 line of code file. So I didn't write the code. So don't blame of me if I say something wrong in detail, but Most of that there is pretty easy to implement there because they have like a really clean API because it's pretty new also, and it's a good example to show. And there, if you want to look, there's the link on the repository. Okay, we have to go further. So there you see like create machine. First of all, you get to get config, and if you go there, we make like this is the spec value, and if you try to marshal it and to transfer it into a cloud-specific code, and yeah, there you have some helper modules like for the Hetzner token and so on, and that's all. Then you have like the config. Let's go back. And if you have like the config, you can then execute it, and you use the client, use the token, and then you parse like the operating system. And with the cloud provider details, cloud provider details are mostly near to the API of the cloud provider. So because of that, there's not much code, but because it's part, you can just add to the payload from the cloud provider pretty easy. And then you apply it together with the operating system, and for that, then it creates the machine object, and you have the machine object, and it will add it to the will be added to a data center. So in a data center, you have like multiple data centers, then you know in which data center run your machine. And if all is done, yeah, you may add the SSH key, someone return, you can return the object, and not the Hetzner server I want to show. Yeah. So that's the config you map. Let's search for the cluster.
Give a location at data center.
What?
I can give a data center as well as location.
It's like
Location is clear. I want to be in Germany and not in France, for example.
Yeah.
The data center.
Yeah.
I can really choose like I want to have this server in RX19 and the next one in R16.
Yeah.
To be like geolocation or
yeah. Normally location is like the country, and the data center will be mapped to like Frankfurt and so on. And that's kind of the spec. Just want to show you the cluster object, but I don't find it. We're on the machine side, of course. So that's the, if you see here, that's the like the machine object, and you have like metadata, provider configuration, versions, and so on and so on. So this mostly specified machine is not hard, so it's not much of code. And also this class of Hetzner has 300 line of code, and it's the latest release. So it's not so much. So if you have time, you can take a look at it and you will understand it, I'm pretty sure. Good. Then, yeah, the machine controller is on the patch 2 license, and we contain currently the machine controllers for AWS, Azure, DigitalOcean, Hetzner, OpenStack, and vSphere. And they are currently included. There is also an option like bring your own, that you can, if you want, if you like hack some other nodes into it, you can like specify bring your own config and edit the node and join the cluster. All right. So if you want to install it, I didn't try it, but it should work like that. Maybe not so easy, but I think more or less you can just install the machine controller, and then you can act over the API at least to create machines. All right. So what's new? Now we also implemented the MachineSet now. So there you can then say, okay, I want to have replicas of machines, and you can then say, okay, that's my template, and there is the like normal machine configuration like you already know from replica set. And the next step would be create like a deployment where you can then create rolling deployments of cluster versions. So automatically, currently you add new nodes with a new version, you upgrade the master version, and then you add new nodes and delete the old nodes, and it also works fine. But this is maybe also not so hard to automate, so we can automate it in the next step. Later on, this will be used for the machine set will be used for the autoscaler. The autoscaler then can get information from the machine set and see, okay, maybe there's some information which kind of machine I want to create.
You use this clone functionality that some providers use then for that? Because you're talking about the templates and cloning a machine usually is a lot faster than like going through the hassle of reinstalling it completely.
There's I would say pre-installed images, so like they are mostly ready to configure. You can then say like upgrade on cluster start or not. Yeah. So what we try now is to create our Kubernetes cluster AWS or DigitalOcean. You can also try it on premise. I don't guarantee anything, but how it is, you can try it by your own. We are not a service provider, so it's just our demo umgebung. Some guys use it like for production, and they mean it's a free service. So there's no monitoring. It's a monitoring for you, testing our monitoring in bigger case. There is no like, we don't guarantee that the backup will work. So we have no operation team that's like 24/7 reachable with that. It's just demo cluster how you can use it. But there the providers AWS, Azure, and DigitalOcean are available, because there you bring your own credentials. You can use your AWS account, you can use your Azure account or your DigitalOcean account to create a cluster, and can play around and scale it if you want. So, but the idea of Kubernetes is that to install it in your kind of infrastructure, and then you can also add different configurations. And it's a product. We don't sell services, we sell a product. So it's one to clarify. So, and this is our brand new development branch, and there we also have like project that you can then come together like a user management, more clusters, and then add different people to allow the access to the cluster. So that's still in development, but I wanted to show it. Like here, it's me in the project, and I have like the SSH key here, and there will be also possible that you have like a shared SSH key, or with user accounts, you just don't need a SSH key. You can just add the users, and all the users are be able then to log into the clusters and to maintain the clusters. All right, then I already create two, so I want to create a third one. Yep. There you can then specify your version. We can already install 1.11, and it's also certified. So then go to the newest, and then you can choose like what cloud provider you want to use. You have preparation. One cloud provider. Huh? That's to bring your own. You can like you get a kubeadm configuration, then you can join your own cluster.
You can change version images for all the providers, because you can select the version for images.
Yes.
So you should be having this image as a provider, right? Or is it like
the Kubernetes itself will be installed.
Server and apply some startup provisioning.
Yeah, we do it with Cloud Init, project, and I'm not sure if they maintain different images. I don't think so. I think they have a basic image and then install the Kubernetes version and start. And, yeah. So decision 3, 2, 1. Okay. I will choose DigitalOcean because the fastest one. And you only have one token. So like that, I have an API token. Oh, it's really I paste it.
Take the photo.
Because this was the reason it's so small. Then you can specify the number of nodes, and you can specify what kind of machines DigitalOcean say droplets, and there you get the information from the cloud provider. So we ask them, hey, what's the size you offer, and then we can choose it. So maybe not to bother my boss, I just use the cheap one. And there we have the different container images, and this is specified in the Kubernetes installation, which maps to what image. So container Linux, because it's also the fastest, and yeah, HSH we would also use Cryo as runtime. If you want to use it, it's possible, but it's not enabled by default. Yeah, and I think you have some additional options. This is also cloud provider specific, like in AWS, you can specify your own network and some other networking stuff. And here, DigitalOcean, you can like say, okay, it should be the virtual machine backed up by DigitalOcean, or you want the monitoring of the nodes by DigitalOcean, and that's like a cloud provider features you can then choose there. And we can add tags. All right, and then say next, and then create it.
So in this case, do you have a seed cluster running in Frankfurt?
No, in this case not. In this environment, it's our play environment or for the developer, so it makes no sense to pay the money for the additional seed cluster. But like this cluster, where all components live, is also not huge. It's like, I think, 9 nodes or something like that. This runs on DKE, so it's just 9-node cluster. And all right, what then happening? First, the master will be created. So the master is like a new namespace on the master cluster, and there the new thing will be started. And yep. So I think this takes some while. Yeah. So I think with that I show you another cluster. When it's ready, then like for our AWS, we have like the API server controller, SD scheduler, and the MachineController. That's like our add-on. And for AWS, we also apply in the cluster like cloud configuration that you can use the load balancer and the storage class. And then you have the overview of what machines you have. And because we are more in the development part, we can take a look to this cluster. So I can download the kube config. I think it's AWSF place. And if I go to my AWS account, I already see this machine's running, and there is like a tag for the cluster. Where is it? Yeah, that's the new one. So that's spinning up here, I think. So
we create the underlying network as well, or do you rely on the existing network setup in the provider itself?
it depends on the provider.
Servers, but these servers need to run in some network, right?
let me show it. So here in AWS, we create a security group, and there you have like your own VPC, and there is the components running.
Part of the job that we click like use back. Part of the job, like when you want to create a new cluster somewhere in some provider.
Yeah.
Does it create the network and security groups and everything else before it creates actually the servers? Or does it rely on existing?
No, it's created automatically.
Okay, all right.
The network. So if they have one, like HeadNet didn't have a virtual private network or something like that. So if there is one, we create it, and then like the master components and the nodes will talk over VPN connection. So for this network to the master cluster, this will be talk between VPN.
So you establish VPN?
Yeah. OpenVPN, yeah. Yes. All right, so I downloaded it, and then I try to. So that's the AWS cluster. I just wanted to show there how to add a node now, and then we can go back to the another one I created. So this cluster is already running, and there I now see that I have an API resources, a new API resource that's here, the machine, and then I can take a look at that. So I can say get machines, and I see, okay, I've created 2 hours before 3 machines, and I can also say so I get information about how it's created. Next step is that we want to apply option. The only thing I did to create this this option is that I delete some like IDs and status from the YAML, and I can maybe compare it live. Oops. Thanks. So this would be the one I want to add, and I can compare it there with them. Right. Well, where? Oh, shouldn't do such things.
It's nice to see that I'm not the only one who has all of these mistakes.
So, okay, and that's the you want to apply, and that's like the current running. So I only deleted such kind of resource version and the status which is running, and then created like the new machine where specified. I think I can hear it better. Specified like the disk size or something like that. I can also choose there another value so that I create a biggest disk and apply some labels and some stuff. And there you see the VPC. In this case, you have to add it because there's like already created a cluster. So the VPC will be created before the machines will be created. All right, then I say kube control apply.
If I have already a VPC on my provider, is it possible to create a machine inside the existing?
Yes, you can choose it like in the dialog, extend it, and then you can specify the if you want to override it. Okay, then let's see. I have this nice watch. So now we already have a machine, and if I connect this, that I see.
Did your machine controller take care of the state of the node?
Yeah. So in this case, currently we see what's happening. So the validation successful create the machine. So in AWS now we should see that there is a new machine coming up. Let's go back. You see here is one machine initializing. That was the name Manuel Tobi. Maybe you don't see it, but here's the name where I created. And this is now being created from the cloud provider. And after that is happening, then you get a new node. So you see, like here, the machine object is here, but the node is not there. So this takes a minute or two. It depends how fast the machine creation is. So it's already created and initializing, so it couldn't take this long. So and then will attach to the new node. Although there you can also like delete nodes from the user cluster also, because and since you don't have the information about the access key, but the machine controller have.
So why did you vote for creating a VPN between all these things? Why did you just take any of the existing network plugins, which also support encryption and authentication and everything?
The VPN is just, so we have Camo here, and that's for the internal. Yeah. And this VPN client is just for the management that we can communicate from our master components to the cluster.
You can do that on the internet. Yeah,
yes. So this is running in Frankfurt, and the cluster is running somewhere else, and this connection is saved over VPN.
But in those situations, yes, I mean, it's a redundant thing. Yeah. With having OpenVPN, it basically encrypts the traffic with TLS, right? But you already have the master API interfaces also TLS anyway. Normally, this is going to have
possibly. Yeah, possibly. So,
I'm not sure what was the decision, so maybe just ask it. We have a Slack channel, you can ask it there. But yeah, that's the connection is between sys components between is VPN connected. So
it's not between the nodes, you're not just managing a complete cluster, it's just about securing the
communication between
to the API.
Yes.
Right.
So that's what security.
Yeah, but it's like in Germany you would say with Kanone auf Massen geschossen, so it's a really big solution for a very small problem.
Yeah, if you spin up multiple clusters, so if you have like 1,000 master clusters.
No, I don't think so. It's not like Canon's Kanone auf Massen. VPN is like very simple, very lightweight. Yeah.
Okay, maybe just skip it to after the talk.
Yeah, the node is there. So.
The node is there finally, and then no. First, let's see if it's healthy.
Those are two things that we should never put into one sentence, just for fun, kill it. It's the node.
Shutting down. You must not know a lot of Americans.
Okay, so there you see that started in kubelet and connected, and we have all nodes ready. And then you want to delete one. But first, I want to show you that it's like also came up in the UI. So we now have here like my specified object there, and also can delete it over the API. Aber wir machen das, we want to do it over that one. Okay. So
Maybe
delete.
you can remove it from AWS.
Yes, that will be removed. So what one? The manual one or
It would actually be quite interesting to kill the node without the machine. We talked about the problem with like double states, right? With the kitty, where you have one state and the other one. What happens
if this get unready? This node will wait. The machine controller will wait 15 minutes, and after that, we will delete it and create a new machine.
Does it mean that it restores it with the provider?
Huh?
By delete, do you mean that it destroys the machine with the provider?
Yes. So if the node is like unhealthy over amount of time, then the machine controller will say, okay, I want to try to repair it and delete the machine and also the node then and spin up like a new machine.
What if you lose connectivity with this cluster then? Are you going to destroy the cluster?
To the cluster itself?
classical split brain problem?
Yeah, but it's another state, so it's
you have the big problem that if for some reason you can't access the master, then you can't get the state of this specific cluster. So the question is, what then? Is the cluster not ready? Therefore, the state has to be repaired. Therefore, a new cluster has to be spawned up, which then maybe like tries to get the same.
Cluster has another life cycle. So the cluster itself. Yes. So you're talking here about machine nodes or machines.
That's okay. On that level.
And the cluster itself has another state. So, like you don't need the Kubernetes components for the cluster itself. So if you have a C cluster and you kill your master cluster, I did it. I delete all namespaces. Trust me. The cluster was still reachable and workable. So they just don't scale or manage something, but they store all information as ST. So they tried then to reconnect it. And as long the cluster object is reachable, they don't delete the cluster if the cluster is not reachable. So there's another state there. There's another life cycle. I'm not sure which different states are possible, but there's another state for the cluster object.
Your node is already not ready.
Yeah, that's some type of connections issue. So he was ready, but you will see that later on. Let's see. Oh, sometimes they're in the starting point you have more load on the node, and this was not like a big machine. So sometimes get unready, and the connection is also not good. Then, but we not delete it like immediately. We just see if it's stable, not stable, stable, not stable. Okay, now delete one. Delete all. So and then there's already gone, and for a cluster is already thrown away, and we will see on the here it's also gone, but in AWS they have the state terminating, I think, or shutting down. So and like in API is you set delete call, and they will confirm it to you, and then we say okay, the cluster is deleted, and we drop it out.
But it's already gone in terms of getting your etcd. It's already data object is already gone. Although this machine might, I don't know, misbehave and fail to stop or shut down or something like that.
You might have a finalizer somehow.
Yes, there are finalizers.
Okay.
So
don't think you can delete the complexity.
All right. Yes. If you like to, there's this upgrade button here. Yeah. Well, this is the newest version. You can then upgrade. So you will upgrade the master components. This is pretty easy for us because it's just like rolling deployment for the master components. And after that works, you can add new nodes and can then specify like the new version of the master will be added there, and the new master version will then be deployed, and then you can delete the old nodes. And that's just the next step you want to automate. So that you just upgrade to the new version, and the whole cluster will upgrade it, or maybe multiple clusters we will see. All right, I think I showed a lot. Yeah, the ticket to ocean cluster I created, by the way. It's like the same. We have here the components. Oh, we have no nodes. Oh, no. Why? Okay. I don't know. Maybe resource limits. Oh, interesting. Just in time, yeah. And sometimes it's like the cloud provider is not reachable, or yeah, here one's yeah.
Maybe the guy supporting this network here in this Kubernetes studio might not be doing such a good job like me.
Yes, I'm sure. Yeah. Okay. So, but the thing is that we can like manage all the cloud providers about one state and one objects, and if like there a problem would be, I think that's weird, or I think their APIs just okay. But the thing is, if like there is a problem, I can take a look at the master's cluster to the log and see, okay, is there like what's the issue with ticket ocean? Is that API calls missing, or what their problem? And then I can then maintain the cluster like Kubernetes objects, so I can see the cluster state. The cluster is not ready because of that, and I can see in the controller creating the cluster phase about this is ID. Okay, and then I really get near really fast to the point. It's out.
Ignore me.
Yeah, okay. It's okay. Spoke too long, so this is the kick out. Okay, so hopefully, finally, someone, we all can already connect. And export. So, yeah, this must be the ocean ones.
Are the cluster names following the pattern, or are they just random?
The pattern is this is the cluster ID.
Okay.
And that's a random name.
Okay.
And yeah, let's see, 2 nodes are ready. Then normally it's like I think 3 to 5 minutes for a new cluster. So mostly it's the start of the VMs. All right. Cool. Then I think we are through more I expected. And yes, what's the status of ClusterAPI? So ClusterAPI currently is just an alpha. That's not our product. Our product is like trusted in production, but the API is back for itself. So there are much discussed. You can think about if you have like Google, VMware, Red Hat, and all the big players want to be able to specify one API. It could take a while. And say quite doing change backwards incompatible currently. So this is also the reason why we just do some forks of them to some given time. And yeah, they don't solve like problems backup and restoring clusters. So that's not solved by the ClusterAPI. ClusterAPI is focusing on creating objects. So you have to be care about that's just create the cluster itself, pure ClusterAPI, and not solve all the problems. But what's the cool thing is you have like decoupling and you provide a specific code. So if you like building up then new application like we built Kubernetes around that, you can use it for multiple clouds. If there's like an interface, get cloud costs. You can then compare how much it costs your clusters on different clouds and can guess there some information. All right, good. And there's also a good part that's like all kind of public cloud provider like Google and private cloud provider like Red Hat are on the table. And so I think if all wants that, and so this will be a good approach in the future to handling clusters. And cluster autoscaler is already possible. Google had it. So, and they also committed that they will open sources. I'm not sure if May is already open source, but they will. Yeah. All right. So what's different? What we build around? So you first of all you have to collect the dashboard. So and we added it like a backup restore concept. There you can like manage all your cluster over one point to backup restore the etcd. And if you want, you can also like add their controllers with Arc that you may then back up all your persistent volumes. The cool thing is you can do it in one place. So over clusters and clusters, and there you have more possibilities. Just if you have like in your organization, if you have 10 clusters, you have to duplicate your backup strategy each time. And yeah, you have the cluster upgrade mechanism that you can automatically change the version for the master components and then for the nodes. It's secure communication between the bootstrapping and cluster. This was VPN with the bootstrapping cluster and the user cluster are secure communication. Yeah, that one master plane, monitoring stack and alerting stack around all cluster components. So in the monitoring, you can then see, okay, if a cluster has a problem, you can drill down the cluster to the etcd and see when the etcd started to get in trouble or something else. And user management is pretty new. So also you can add then over DEX users and roles to the clusters. So it's like RBAC then will be deployed in the user cluster. It's not really official release, but it's kind of 90% ready, alpha beta between.
90% from it. Oh, yeah.
No, I see it already. So it's just to we not say production ready. So, but yeah, this will be the next step that you can say, okay, who is cluster user, who is cluster admin, who can maybe not delete machines, and who can do it. And yeah, so it'll be released soon. Yeah, and if you want to try it, maybe there are not all features reachable, like monitoring, logging, and so on, but you can use it and play around. I use it for my own. If I have to do something with containers on my private, I use my private DigitalOcean account and create the clusters there, and yeah, then delete it fastly. For me, it's faster than to get a virtual machine and install Docker or something. Yeah, then, questions?
Lots of questions. Should we do the applause first?
Yeah.
Maybe one note. In January, there will be a new conference, Go Days, in Berlin. And if you want to join, feel free. And we have here a lot of stickers. So if you want to have one, feel free to grab one. And yeah, the tickets are limited. So be fast. We cannot guarantee that everybody get one. But there will be a Go Days in January 29 and 30. So feel free to come. You will be happy. Yeah, and then already we are hiring, but I think you know it. Thanks.
You have a question, I go first. Imagine that you have you're a consultant with 2 employees. How far can I go without paying for products? You have 25 employees, you have to pay the bill somehow. So how far can I go without having to pay you for anything?
If you are able to build you're around the MachineController, you have to build.
Can I download Kubernetes? What you've shown us, can I download and play with by myself?
No, Kubernetes itself is a product, but you can do the MachineController.
Okay.
So you can create machines, and therefore you can just need to. I'm not sure if the cluster definition as well is open source, but there are control plane and they're like backup and all the stuff you have to build by your own.
Okay.
Currently. Yeah.
You mentioned that you have existing clusters, like 50 clusters and various providers.
Yeah.
And you want to adopt this one whenever it becomes stable enough, let's say. You have the option to basically port existing clusters and continue using that functionality.
Cool.
So what you showing them is how do you start from scratch?
So you mean like if you have already the infrastructure of X clusters and want to add them to Kubernetes and
yeah, so you can basically do this like you mentioned, later on you're gonna build in measurements, how much do you pay this provider,
I think I'm not sure if there is like an automatic mechanism, but you can install the objects. So you can install the APIs in the cluster, and then it should be possible that if you do the configuration right, they will appear and also be manageable. So because all clusters
have to deploy some applications on the existing clusters and make them with this one, with this tool.
Yes. So
aren't you really opinionated? I mean, you have to have a lot of opinionated decisions. For example, which network provider, which network provider not provider, but which network plugin you, for example, use something.
I think that's not the use case currently at our product, but if this is like a requirement for migrating an environment, there would be a way to do it. But mostly you start from scratch and building up new clusters and maybe federate the clusters and move the workload over.
You're talking about your own machine or Google cluster? I think it's not possible because Google cluster didn't exist from a bunch of VMs. This is managed anything by Google.
If you use GK, you use Kubernetes spun up by yourself, like that. Yeah. Just in case it's like this, even though you can modify some stuff.
And like GK, the master components are intransparent; they're not visible for you. So
in GKS, they're not visible, I think, but in GK, you can manage only not right.
Well, that's the great thing about Kubernetes is that if you set on Kubernetes, it's essentially a set of APIs and reference implementations. You don't really have to care. And the worst thing that can happen is that you pay for like a day delay of the cluster in double until you move all of the workloads over. So you just create a new instance with Loodse, move your workload over, arrange some IP changes, some DNS entries manually, and after that.
Always the case. Clusters, and those clusters are owned by different entities within the organization. So it's not really that easy to basically go and solve all these guys. Like imagine that you have 50 different departments within departments, and then go figure how you're gonna communicate that change with all of them.
Changing the name there will take time as well.
Yes.
So but you will have to do it, and you have to do it one by one anyway. And it seems if you have that kind of infrastructure, that usually indicates that the departments are responsible for like DevOps, so they're responsible for their own clusters, right?
No, the reason I'm asking is because if you're able to basically import the existing clusters, you don't have to go to speak to so many people. You're not doing basically a huge change for them. Like if you want to just use analytics, for instance, that I was mentioning, you don't really need to go and speak to all these different people. You just have to connect and deploy this application that you mentioned. And you link them all together and you start doing stuff.
Thinking currently it's like the current state of at least the ClusterAPI itself is not stable enough for ClusterAPI, but if you use our stuff, the use case mostly wasn't there already. So, but there are all components are just components like custom resource definition. If you are able to define your cluster in the meta orchestrator level correctly and then connect it, it would be possible. But if you have like the overlay network of we currently not support, maybe then we have cannot deploy a new node or something like that. So for this case, we have to ensure that the clusters will be like kind of getting equal. So.
And additional, you are the owner of the control plane of each of your clusters. And in this case, control plane already exists.
Yeah, the control plane is in the user cluster. So, so like here in the new created cluster, we also deploy a control plane of Kubernetes itself. So I think there's.
The control plane is not in the C.
No. So it's like EKE does it. So there you also get your own, and I think you can go there over this. And choose your config. Was the right cluster? No.
I think you just exported it at the top, did you?
This was the wrong idea. Idea is
I'm not sure if you exported the kubeconfig on the lower terminal.
yeah.
So you might actually have.
Yeah, sure. That was the issue. So I just can export this one. It's too late. Try again. All right. So yeah, the cluster we created. So that's the normal control plane, which is like the Kubernetes default control plane. So we not install additional components. If you look at the components we install here, you can also look at here, all namespaces, pods. The only that's our components for the kube system. We also have in other clusters, and only thing like the kubedns that we get information from, we can connect on top with them. But all the other components, there is nothing like special Kubernetes branded. So you can also like choose what you are applying in the cluster. You have like an add-on mechanism where you can add additional resources like storage. So we know the storage provider, so we can enable the default storage classes for the cloud provider, and that we also implemented. But if you want to use like something Rook or so, you can add like an add-on which will be applied after the cluster is ready and install like then the class. And it also takes care if you change the add-on, then the add-ons will be applied for other clusters. All right. More questions? Okay, then I think we can stop for now. Thank you very much.